I'm a piranha.
Hey, look at that. So let's try that again. Thank you, Nixie. So yeah, what I was saying is we are going to cover some beginning programming concepts that I wish I would have been taught in college. Uh, we, when I went to college, they handed us a programming language, said, do your coding. And that was it. They expected us to figure everything out. And it's okay to throw people to the wolves, but I feel like if you learn the basics of programming, you have a better chance of not becoming dependent on a language. So you'll hear a lot of people, oh, I program in Python, I program in C Sharp, I program in C++. And they get this concept that that is what they program in. If they understood the basics from the beginning, they would understand the big difference is the syntactical sugar, right? So at its lowest level, we're giving instructions to a computer. Those instructions get performed by the computer, and we get an output. Doesn't matter what language we're writing in. That's what happens. So if you start at the basics, you will be able to move between languages. It's just figuring out the syntax. I do want to talk a little bit about low level versus high level. I don't want to go too far down that rabbit hole because that's an extremely confusing topic. So when we talk about high level languages, we mean, and in its purest form, we mean a language that is more user friendly. So we are writing words that make sense most of the time. We are allowing the actual process of the machine figuring out what we wanted it to do to happen at the lower levels, whether that be through an interpreter or a compiler. We'll talk about that in a second. Again, not going too deep into it. But when we talk about low level, the lower the level language, the closer we are to writing machine code. So at the lowest level that most people will ever write code at, we would be talking assembly. So that's machine code. We're basically directly controlling, I need you to move this data from this register in the CPU to this. I need you to do this to it. And it's a very complicated language. I do write a little bit of assembly. We will not be writing assembly here. Just because, one, it's ugly, two, it's complicated, and three, that's, in my opinion, probably the quickest way to scare people away from programming in general. I think Nixie would probably agree with that. So we talked a little bit, truth. We talked a little bit about interpreted versus compiled. So interpreted, I don't know. Nixie, should we talk about compiled first or should we talk about interpreted first? What do you think? Of course you leave it up to me. Okay, so deep down that rabbit hole I really want to get. Okay, so in a compiled language, the target machine is going to translate. We get to ask the things eventually. Yes. So in a compiled language, the target machine is going to directly translate the program. So what that means is there's no it. How do you explain that? Basically, the compiler takes it from what you coded directly into the machine level code. In an interpreted language, you have a different program called an interpreter that actually reads and executes. Some of them use a virtual machine. Some of them use a couple different things. I think that's as deep as we need to get into that. Just because, again, without going into how machine code is executed differently than other things, I don't want to scare anybody off. um, just because a language is high level does not mean that it is interpreted. Just because well, if a language is truly low level, it is going to actually not be compiled or interpreted. It's going to be assembled and linked. Uh, Depending on which definition of that you go with, the newer definition puts things like C++ at a much lower level than it used to. So I think that's enough of that rabbit hole because, yeah, that gets really deep really quick. So turns it into machine language the computer understands. Computer does, yes, the computer does its boot beep things and returns the things. That is such a friendly way to say that. Uh, we could get into a really fun debate if there was Python programmers here, a lot of Python programmers. Uh, that really fun debate is whether or not Python is interpreted. You can tell I talk to students. Yes. Uh, Whether or not Python is interpreted or compiled, and the answer is technically it's both. So Python gets compiled to a C code variant, and then it gets interpreted by the Python virtual machine. That's as far as we're going into that because, again, it's just not a fun topic. So let's dive into actual programming concepts. Um, I think the first thing we should probably talk about is what are we doing when we program? Uh, I know we mentioned we're giving the computer instructions. The computer does executes the instructions. We get an output from those instructions, and that's our program. Um, Inside of those instructions, we are doing things like processing data. We could be doing math. We could be doing taking an input. We could be manipulating words. Uh, we could iterate through different things, and we'll talk more on each of those topics. But for the biggest thing that I tell people when I'm teaching them when they first start is to understand a computer is only as smart as you allow it to be. It If you don't give implicit instructions, it will not give implicit results. Uh, there is an old hi pizza, how you doing? Pizza was my 100th follower today. Um, but yeah, if hey, thank you for the alert, Tiny. Thank you. Um, so yeah, in college, one of the things that they love to do, uh, yes, uh, AI programs are only as smart as the person who programmed it, and they also accept all the biases that were intentional or unintentional. That is why it is a very long way away from AI taking over the world. Uh, to be completely honest, it's not going to happen in our lifetime. Um, we just don't have the compute power. We don't have the ability to do that. I say that, and now tomorrow AI will take a giant leap and take over the world. So that's how that goes. But yeah, so in college, one of the few basic things that I did have to do, and Nixie's gonna love this one. I know it because every programmer hates it. Um, we did a peanut butter and jelly sandwich instructions, and it gets very frustrating very quick. Basically, the instructor brings you and you write down this is how you make a peanut butter and jelly sandwich, and then the entire document you turn in, they come back and put red lines through it and tell you how you didn't do a very good job of explaining it. Most people, oh, you didn't have to do that one in college? Oh, maybe my college just was jerks. So a basic idea of that. I don't want a bunch of red lines. So make a peanut. That's fine. Thank you for lurking, pizza. Way more complicated. Yeah, yeah, definitely. We definitely moved from this one pretty quick. Um, do I know how to spell today? I don't know how to spell today. So this is cheating. I don't like asking Nixie this question. All right, Nixie, what's the first thing you do when you make a peanut butter jelly sandwich? And don't think like a programmer. Uh, a lot of the examples that I saw started. I know, it's impossible to turn that brain off after you have done it for so long. So what I'll do, kind of, yeah, get out bread. So we get out bread, right? And then we'll do proper things. Number two, what's the second thing we do? Uh, most people, or at least most of the people in my class, yep, get out peanut butter, uh, get out jelly, get out Haxty. That's fine. What are you doing? Uh, and Nixie already knows where this is going, because in a second we're going to tear this apart and tell you where all the errors would happen with the computer. You are, and you're doing such a good job. I am surprised you pulled out of your programming brain that well, that quick. So yeah, after we get out a knife, we're gonna open the bread, right? Sound good? Yep, open. Open the bread. Open the jar. I like that because Nixie is really getting ready to set up some kind of errors. What do we do next? Yeah, I can tell you've dealt with that. Oh, yeah, that exactly. So uh, that is going to be an error. Uh, use knife. You get peanut butter. I'm just going to call it PB because I'm tired of typing so much. What else? What else? Uh, yep, perfect, perfect. I love it because these are these are exactly what we see. Open jelly. Dirty knife. I like it. Yeah, yeah, keep going. Um, spread jelly on bread. Awesome, awesome. So we got. So now we've got some peanut butter on some bread. We've got some jelly on some bread. Closed sandwich. And I'm going to bake that into 2 steps. And what else? What else are we going to do? Enjoy sandwich. Perfect. All right. And anybody who's had to do this exercise before knows that, especially if it's your first time doing this exercise, this is a pretty fair. Yes. Now we debug. Um, this is a pretty fair representation. We as humans can look at this and say, absolutely, I could follow those instructions and make a peanut butter and jelly sandwich. We could. A computer cannot. So let's go right to instruction one because this is going to be an error. Nixie, what error are we going to get? I can tell you the first one. Icy. Um, yep, yep. We're going to get an exception. And what does this mean? Nixie is doing exactly. Are you sure you weren't my college professor? So yeah, the computer doesn't know what bread is. It doesn't know what get out means, and it doesn't. We didn't tell it where to get this item that it has never even heard of. So yeah, where am I getting this from? So we're not going to fix it, but let's go to the second one. So what's going to happen here? We're going to have the same things, right? Yeah. We're going to get what is PB? What is get out? Where? What? Where? How? Exactly. And I mean, literally, I can. The only thing that's going to change is jelly, knife. Hey, hey, take care of family first. Uh, Here we're going to say what is open. Uh, we already know that we don't know what bread is. This one, Nixie, we're gonna tear this one apart because I love. Yeah, how do you open? How do I open? Um, and then, again, we're not going to go all the way back through it because we're getting the point. But I do want to do the jar thing because there's some really cool exceptions that would happen in this. Um, and the first thing is, what is a jar? Which jar? Yeah, yeah. I don't know if we're going to get into threaded, mainly because again, I will have to pull up a different IDE in a different language if we want to do threaded. Um, yeah, yeah, yeah. I mean, there's so many different errors, and I mean, again, we as humans look at this and we say that is a perfectly logical explanation. So, how do we get the computer to understand um, what we already understand? And that is what makes. And I'm going to boast on software engineers for a minute because they are an extremely special group of people because this is what they are good at. They are good. Don't do it, Nixie. Most of them are very good at saying, this is what I need the computer to do. this is how I'm going to design it to do that. Um, and as with anything, the longer you've been doing it, the better you're going to get at that. Uh, but yeah, this is where the design process comes in. So let's take it down. How are we going to answer this question? What is bread? And this is going to lead us into data types a little bit, and variables, because variables are important. Anybody who did not like algebra and who ever said, I will never need anything I learned in algebra ever in real life, if you become a software engineer, you need stuff that you learned in algebra. I promise you. Uh, the concept of a variable is the most basic thing. So we need to create a variable named bread, and oh, so much algebra, so much algebra, and that's without even getting into just the concept of the math that we can do with a computer. That's just the concepts of how we actually program. Um, so what does this mean? We now have a variable called bread. We're going to define it. So what would our we're going to keep the pseudocode. We're not going to get into actual programming just yet. Um, so the next question we have to do is define what get out means. This is going to be a very specific type of thing. It's called a function. Function tells the program, I need you to process something. Easy way without overthinking it. It's explain it to a robot. Yeah, yeah. I mean that's exactly what we're doing. Um, we're. I always tell people computers, if you think explaining to your 2-year old is hard on how to do something, a computer is 100 times harder. Um, in this case, our function is going to take an input, and there's a reason that I'm doing this. Uh, going to perform an action. No, 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 no. No. Uh, let's stick away from memory management for this particular stream. We'll do one. I'll tell you what, Nixie. I will pull out. We'll do C. Yeah, yeah. That's a good way to scare him. We will pull out some C code, and we will actually handle a little bit of memory management at some point. Much further down the line, though, because yeah, memory management gets scary. We're going to perform an action. We're going to return a result, right? That is what a function is. So in this case, how would that look?
Oh my god.
Roadside. Uh, yeah, yeah. That is that is true. All the questions, exactly. I mean, and once we step into that point, now we're getting further into user design. So what does who am I designing this program for? Am I designing this program for me? Exactly. If I'm designing this for me, I probably don't need an input. I know how I like my peanut butter and jelly sandwich. No, no, it's good, Nixie. That's what I want. This is the point of this particular type of stream is for anybody who watches it to understand the concepts, the basics. Like these are the types of things that we as well, you as a programmer, me as a person who writes code on occasion, try to look at. Um, oh yeah, exactly, roadside, and exactly, Nixie. Roadside will troll your engineer brain as much as possible. But yeah, that's the types of things that we're going to get into further into the design process. Again, if I'm making this for me, I know how I like my peanut butter and jelly sandwich. I know how what brands I like. I know where everything is. So I'm going to have to define less things if I am the only person that will ever use it. But how portable is that? You know, cool. Ryan has a peanut butter and jelly sandwich program. Oh God, here we go with the Django. I mean, we could. We absolutely could. If I was going to do that, probably I would probably break out some C sharp, which I know you would absolutely hate, Nixie, because I write ugly C sharp um, with ducks. No ducks, not the ducks again. Um, but yeah, we could do that. I would want to bring out C sharp, maybe actually let people see what it. Uh, I don't know, Nixie. I'm pretty freaking Django. Yeah, freaking Django. Uh, like I told you, Roadside, when I am ready to do some Django, we will bring you on as a guest star because Django is not my framework of choice. I am not good at it. I don't like it. It's not that I don't like it; it's that I don't build anything big enough to use it. Um, but yeah, we'll bring you on as a co-star, and we'll do a code with me. Um, well, to be fair, Nixie, you don't like anything that is Python based. And I get it. When you are used to using a strictly typed language, um, yes, sips tea. Well, coffee, because coffee at 11:17 at night is a great idea, especially when I have to actually get up for work early. But yeah, when you're used to a strictly typed language, moving into a duck type language is frustrating, especially when it complains that that's the wrong type, and you're like, but you don't even ask me what type I wanted it to be. Um, all right, back on track. Uh, where were we? you guys, you guys, you guys are like the perfect ADHD triggers. uh, Spread functions, yes, spread functions. So we need it to. We're not going to get too deep into a function right this minute. I, no, roadside, you're not the problem. You may know how to nerd snipe me. You may know how to get me off on tangents, but you're not a problem. I it's very I think you have to at least have some form of ADHD, whether it be high functioning or deep in the woods with it, to handle doing this for a living. Um, just because there's moments where you have to get hyper focused, and then there's moments where you have to let your brain go squirrely for a minute. Um, at least I do. So there's a reason that I specifically wanted to make this a function. We don't have to make this a function. We could just define what it's going to do. Truth. Absolute truth, Roadside. There are times where I have literally been coding and woken up sitting in my chair wondering where in the hell the time went and how I fell asleep. And I look and I've typed weird things with my forehead. Um, I I feel that as well. So I get spurts, and then I believe it was at the same time that certain passwords were being used. Um, but yeah, Nixie, I do spurts, and then I'll do like a long term hyperfixation, and I'll come out with 2,000 lines of code, and not realize that I forgot to eat, I forgot to drink anything. It's bad. All right, so the reason that we're going to do a function, uh, roadside Nixie, can you take a get? Not Nixie, you're a cheater. You program for a living. Roadside, why would we do a function instead of just telling it the action it needs to take? So I could just say, move your arm this way, move this, and I could do that one time, and poof, it does what I told it to do, right? The reason that we're going to use a function is, and Nixie, I was just kidding. If you want to answer it, you can. Functions make code reusable. That is right. So if we defined how to get out right here, and we just made it a single use thing. So this is how you're going to get out bread. We're going to have to do the same thing here. We're going to have to do the same thing here. Cheating. We're going to have to do the same thing here. We type too much as programmers. We type too much as IT specialists. Don't type more than you have to. There is a programming concept called dry. Don't repeat yourself. Exactly. Do not repeat yourself. If you are doing something more than once, unless it is just way more complicated to actually make it a function, there are some times where that won't apply. But for the majority of things, if you are doing it more than once, it needs to become a function. There's a couple of reasons for that. One, stop typing so much. Number two, if you create a function and you find out that all of a sudden your robot that you are creating with this code gets 3 arms instead of 2, if you have defined this multiple times, yes, if you have defined this multiple times throughout your code, you are going to have to go back and change every definition that you created. If you create a function and you reuse that function multiple times, you redefine it in one place, that affects everywhere that that function is used. So, when you hear updates, I think everybody here plays games. You hear an update because lighting was broken in the game. We're not picking on any games. When the developers go back and patch that because they were smart. Oh, yeah, no, absolutely not. I don't have the attention span to fix even the what, 6 uses. If they were smart, if they followed lazy efficiency, exactly, lazy efficiency. If they followed dry programming, the lighting, because it is going to be used everywhere that that lighting function is used, they go to one spot, they patch it. That is it. Everywhere that it was used is now fixed. if we don't follow the 99 bugs in the code. Because that is definitely what happens once you fix one thing, you get 234 more things that break. That's where good QA comes into play. But we won't talk about QA. Or they overdid the whatever they used to fix the lighting. I mean, true, true. There is the risk that if you repair a function and it only needed to be repaired in that one spot, that you have now broken it. Oh, roadside, why would you do that? That is such a nerd snipe. Okay. Function, get out. uh no, we gotta talk about that. So yes, there are times where dry can kind of come back to bite you in the butt. But if you're decent at design, you only put in to the function what needs to be there for every location it will be used. Anyway, that is great in theory, terrible in practice. So yeah, we're going to create a function. We're not going to actually write the function yet. We're going to get to that part in a little bit. But so for example, what does get out mean? What do you think, roadside? What does get out mean? What is the one thing, or what are the things that getting out is always going to have to do? Uh, sorry. Uh, Still trying to get over this cold, and that's actually why I took so long to get to stream. I had to get the cough to stop a little bit. So yes, acquire the item. So the way that I would look at this function, every time we use it, it is going to have to go to a location. We're going to use move because we don't want to get too deep in the rabbit hole. Roadside, Nixie. I'm not going to ignore that. Oh, that'd be cool. Dude. Okay. So move to location of item, right? Before it can get it out, it has to move to the location. Uh, so now what we've done is we've created more things that need to be defined. And we're going to pass the item. See, please share that with me, or roadside, either one. Thank you. I want to be a nerd too, guys. Come on. So what do we mean when we say pass an item? Uh, Actually, we would have to pass this as well. But don't look at it. No, I'm not going to look at it on stream. I will never get through this. We will be here till next week while I go pull out all of Danny's Hot Wheels and try to build it tonight. To location. Oh, are we getting a little bit too close? We're kind of getting into. We're just gonna pass it. No, because we haven't talked about arrays yet. All right. That's actually really fair, though. We do need to get to data types because I don't want to just keep no arrays, no arrays. So we don't want to build a queue. Keep it simple. Fair enough. Don't keep up with the good ideas, Roadside, because like Nixie said, I think it would be really fun. It's either going to be in C# or Python. Depends on how lazy I get. We can actually program this at some point, and we'll actually show what it would look like. And from there, we can go into like how could we make it better. Um, I do want to get through some data types before we do that, which we've been talking about slowly but surely. But I think okay, yeah, yeah. Okay, so we're going to go to the very bottom. Get out of the corner. Actually, here, Roadside. You want to be in the corner. Now you can go figure out what to say. um, I spelled sandwich wrong again. All right. Trust note. Oh, I like that. That is uh double float. Ooh, we may not. We may not go into the double float with that. Uh, we'll figure something out. But yeah, yeah, I like the. I like where you're going with that. All right, so uh, since we're now going to get into defining some variables, because we have to use. Actually, real quick, I'm going to take just a couple second break, and we will actually. We're going to write some Python, and Nixie is going to have a heart attack because she hates Python, and Roadside is going to stick his tongue out at me. You'll live. Uh, it's all language, exactly, and that's what the concept I want to get across to people. Um, all of this applies to every language. It's just how you write it. But we're going to take a quick break, and we'll be right back. Yep. I caught it a little bit quicker that time. Not no more. No, thank you. Seriously, I forget all the time. I've got to put that onto the stream deck so that it doesn't, so it actually unmutes me. But yeah, let's talk data types. Actually, that's good. Nixie strings, integers, or well, strings or integers first. Which one do you want to do? Or anybody. What is bread? All right, so let's do a string. All right. So the first thing I am going to mention, and this drives me crazy in programming, please, when you name a variable, make it something that makes sense. Your variable should not be named for bread I equals blah. That is an example of something that will have Nixie come to your house and stomp on you if she has to go back behind your code, because she is not going to know what in the heck you are trying to do with that letter. There are some cases where I is okay. For example, I do not have a problem if I see 4i in and it is a very simple iteration. I'm okay with that. But something like this, exactly. If it is something where they can look at it real quick and say, okay, I know what that is. But if Nixie comes back behind me and she sees I being passed to a function 400 lines of code in and has to go back to where I have declared this variable, I can guarantee you I will be called some of the meanest things in the book. Versus description of bread. If she comes down 500 lines later and sees description of bread being passed into a function, she's going to know what that is. She's going to understand that. And if she doesn't, at least she's going to look at it and say, okay, I mean, I don't get it, but it's pretty close. You want to, okay, cool. No, the IDE will, white beard. That's what I'm starting to get. All right. So what is a string? That popped up just as I said that. That is awesome. In computers, what a string is a collection of characters that can be used as words. Fair description, Nixie? Um, when we use names, when we use descriptions, when we want to output something to a screen, alphanumeric and special characters, correct. Now, the numeric is going to be really fun because there is a difference between a numeric character used in a string and a numeric character used in another data type that we're going to go to next. Basically, that means these two things, even though we look at them as the same, yes, yes, you can use anything in a string that your keyboard can type. But these two things are not the same. even though we look at that and we say that's a 1, and we look at that and we say that's a 1, the computer does not look at it like that. In other languages, you will have to declare what type you are going to use. That is why Python is called a duck type language, because if it looks like a string, if it quacks like a string, it must be a string. There you go, Nixie. I brought up your ducks for you. And we can actually see this. We are going to write a very simple thing. And we'll do a string times 3. And yes, you can do this in Python, Nixie. I know you're not going to like it, but we can do this. Remember, as in, we're going to make sure that nothing is going to fail. Good example is, do we want to do concatenation instead of, yeah, that's probably a good idea. Instead of using multiplication, we're going to do this. All right. So again, as humans, we look at this. This is a 1. This is a 1. So 1 plus 1 should... Actually, that won't work because you can't do that. Yeah. Yep. So we know that this is how the... let's do consistency. All right. So as humans, we would expect this to print out 2. We would expect this to print out 2 because they are both 1. That is not going to be the case. If we run main, we are going to get this, and we are going to get 2. What's happening here is what's called concatenation. So that literally, to do a comment, this is going to do math. So this is why it is important to know what type of data we are using. Yes. Yep. Python does some cool stuff. We can actually... Most languages would have a niche and fit if I did this. Python does not, because, again, duck type language. All right, so let's take a guess. What is... We'll remove this comment because that is no longer true. What do we expect for output? And again, Mixie, I know you're going to hate this one, but... So if we run this again, we are going to run main. So in Python, we can use math on strings, just not with the plus, because that it just freaks out and it says, no, I can't do an integer to a string. But yeah, so here we printed out the character 1, the string 1, 3 times. Here we did math, and we got 3. This is, again, this is something that is Python specific. Not all languages will do that. Most languages have different ways of doing that. But yeah, so here we have a string. Here we have an integer. I'm sorry for all the coffee. So let's make our number as an integer something bigger. And we're going to do some math for a few minutes. We don't want to do that. We want to use our variable. All right. So what do we think we're going to get if we divide 10 by 20? Most people know that we're going to get a decimal point, right? This is a problem with Python being a duck type language. It is very hard to show certain things. It recognizes, so we're going to change that data type. In every other language, Twitch didn't like your answer. What? Twitch be twitching. So in every other language, this is what's going to happen if you try to run the same code. We're going to get a 0. And the reason for that is we are telling it we are using a data type integer. We're dividing it by an integer. Python likes to do crazy things and assume types. What we saw originally is what we would call in some languages, a double. Python does not have a built-in double concept. Python would call that a rounded float. And actually, that's not technically true because it doesn't automatically round it for us. We need something that'll so this is what a float looks like in Python. If we wanted that to become a decimal, Mixie made a good point. A lot of the time, what we consider when we're talking about doubles and, in this case, a rounded float, we think about currency. So and we run this. And of course, it wants to just do crazy things. Um, because zeros. Yep. 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 It does a true round. So if it's below 5, it rounds to 0. If it's above, it rounds to the next number. So, this got rounded to 1, that all got rounded to 0, so we gave a 1.0. It keeps it as a decimal point because it wants us to know that there was additional decimal points. It's not going to show 2 zeros because computers think that is a waste of time. Are there any questions about integers or floats? Floats are probably my least favorite data type, other than something we're not going to go into today. Actually, gone over that. Let's actually make this make sense. Yep. Pieces of bread. 2. Do we want to talk about booleans? Crust. Yes, for roadside. So we're going to talk about a new data type. This is called a boolean. There are 2 types of booleans. We're not going to get. Yeah, we're just going to go with true and false. All right. So for this, we'll erase this part. We won't erase it. We'll just. So again, like roadside said, do we want crust? So let's stick to easy. This is how we define a boolean in Python. We just call out our variable and we give it true or false, which is great. We can. I agree. It does. So I actually was going to suggest that we do something different, though. This would be a great point to talk about a little bit of involving the user. Um, I don't know how far we want to get into that though. But we're just going to take and say it is true. So now we have a description of bread. Um, we have it's white bread, it's pieces of bread, and we're going to have crust on it. So how would we use this? Hi, welcome in. Do we get into functions? What do you think, Mixie? Yes? Okay. All right. So we're going to define a function. And remember, a function, I'm not going to have it get bread just yet because that's going to require a lot of actions. What I'm going to do is do a simple function to describe the bread. Sound fair? Um, Now you kind of nurse thinking that it'd be fun to actually write out the get bread. Let's save that for when we start talking about OOP though. And we're going to take in inputs or parameters of type of bread. And you got to see something really fun, which is when do we realize that we actually named something probably really bad? Uh, Even though crust is true here, I probably wouldn't define that as a variable. Um, at least not in this fashion, just because that got really confusing. All right, so we have a function. We're going to pass, so I stop seeing that red line because it bothers me. Um, I'll explain what we're typing here in a second. All right. So what we've done, we've got some parameters. This is another Python thing. These are called f strings. I'm going to print out what type of bread, or how many pieces of what type of bread with the crust on or not. Um, we would actually normally return this because that's the proper way to do it. So an example of how we can reuse functions. Ooh. Mm, okay. Okay, we're going to use a new, so this is a function. This is a built-in function of input. What that's going to do is ask us the question. To use a little bit of logic. If that's not, or you wanted to do pull the string decision structure. I don't know. No, we don't have time to design all that right now. See, Nixie knows she hurts sniping. That's all right. Okay, that's fair. If anybody didn't see what Nixie typed in chat, we're just going to do a very simple uh, if statement. We're going to say if pressed on or no, it's equal to true. Thank you for the raid. How is everybody? Welcome in. We are doing some basic
Oh my god.
programming. How are you, Dahlia? Thank you so much. If anybody here does not know who Dahlia is, what are you doing with your life? Um, we are doing something very different than she normally does on her streams. She is an amazing variety horror streamer, and I love watching her play different horror games. Um, and she's just an amazing person all around. And again, thank you so much for the raid. Um, so yeah, today we're doing a little bit of beginning programming concepts. We moved a little bit further into the coding than I expected to. Yeah, programming 101. We started off with everything from what a high level versus a low level language is. We've gone into we did the actually we have notes. We did the peanut butter sandwich example. And then we started breaking it down and debugging why instructions wouldn't have worked with the computer. Uh, now we're actually going to do a simple function. We are going to code in Python. Originally, I was not going to code in Python at all because I wanted to keep it language agnostic. Welcome in, honeybee. Yes, yes. And I think I actually may have described them as extremely dumb. Uh, but yeah, we're actually going to do a simple function. Um, Nixie nerd sniped me a little bit, and now we're actually doing a little bit more complicated of a function than I expected to, but that's okay because it's not much more complicated. Um, Again, I'll explain kind of what we're doing here. Thank you, CJ. That is awesome. And welcome in. Thank you. I, I should not be as rusty as I am. I'm supposed to program this stuff every day, but I don't. I get too busy doing other things. We wanted to say rest on. We're going to do an else statement, which is dangerous, but we're going to do it anyway. You don't even. No, Nixie, you don't. But that's because you hate it. Yes, yes. One thing I will reiterate time and time again during this particular stream. Uh, it is so important to learn the basics and the logic behind programming, because once you learn those basics and that logic, it does not matter what language you want to learn. You can learn it because the only thing that changes is the syntax. Uh, for the most part, without getting into memory management languages versus non, because why are you complaining? There is. There is. Yes. Mm. I always have a syntax error. It is guaranteed I will have a syntax error or something stupid. Yet Python does not like the single equals because that is how we define a variable. It likes this one because that is how we compare. So yeah, so what we're going to do, we have defined a string. I erased my integer. Yep, yep, yep. How are you doing, Chinggis? It's good to see you. No, Dahlia, seriously, go de-stream and take care of you. It's a very popular language. That's why I tend to use it. As we get further along in this, I'll probably step into one of the slightly lower level. Right? See, and we just completely skipped that part. We we did not actually do the most common first. This is your first program. Print hello world. But that's because Nixie likes to nerd snipe me. But yeah, okay. So we've defined a string of white bread. We've defined pieces of bread, and we are going to put true for crust. We're going to define a function as a parameter. We're going to take the type of bread, the number of pieces, and crust on or no. If it is true, we're going to change it to crust on. Else, we're going to leave it to crust off because technically, because that is when you know that you actually wrote your first program in that language, Nixie. I hope that feeling never goes away. When I started learning Go last year, I, I personally agreed. Yeah, oh yeah, yeah. All of the JetBrains, like this thing's ignore function names should be lowercase because Pep 8 says it should be. But yeah, all of the JetBrains IDEs are just terrible for yelling at you. So let's go ahead and use a function. So the way that we're going to actually run this, we did return. So the reason that we're going to use a print, instead of printing here, we're going to return this because I want to show that normally we would return a value after it's been processed. Where's camel case? That's fair. See, Python, no matter what, technically Python should never use camel case, though. but that's a standard. Uh, and honestly, I don't care if you use camel case or not. All I care about is whether or not you use good variable names. So we are going to, what did I name that? Describe bread. So we're going to call our function. We're going to pass it bread. We just used white bread. Get the order right. We're going to pass it white bread, pieces of bread, and we're going to pass it crust. So what this is going to do is we are going to pass to this function. The type of bread is going to become white bread. The number of pieces is going to become pieces of bread. And the crust on or no is going to become true. We're going to use some logic to say, if it is true, I want you to change it to the string crust on. If it is not true, or else, if it is anything other than true, we are going to say crust off. Yes, we did. Yeah, we got a bunch of stuff in. And in a second, we're actually going to do some fun stuff to show like why we were talking about dry programming and why that is so important. Okay. All right. So what we should expect to see is you are getting two, we forgot the word pieces, of white bread with, this is going to be true, so crust on. And as long as I haven't completely forgotten how to do Python, that is what we should see in this output. So we are going to go here. We're going to make sure that I haven't done anything crazy like forget to comment out old stuff. And as you see, so you are getting two pieces of white bread with crust on. Thank you for the follow. So yeah, that was successful. So again, we need to show why this is such a useful thing in programming. Also, integers are whole numbers. Correct. Yes, integers are whole numbers. Decimals are floats or doubles. In Python, only floats. And Python does assume that if you were going to get a decimal back, that you wanted a float. It's, again, a duck type language. So if it looks like a duck, if it walks like a duck, if it quacks like a duck, it must be a duck. So what happens now if we do this, but instead of passing that white bread, we say, give me another type of bread. We were almost completely in sync there. We're going to do one piece because they only want half a sandwich. And we're going to say false. The reason functions are so useful is we can change the inputs that we put in and get the same type of result. Now, this is an extremely basic function. There is so much more that we can do with it that we are not going to do tonight. But we are going to at least see what this looks like. So we are now getting two pieces of white bread with crust on because I left this here. But we are also getting one piece of honey wheat with crust off. So again, it checked to see was this value, which is here, true. Yeah, so we'll get to that. So There is some other logic that if we were actually building this out, we wouldn't want to say this statement. We would actually probably want to do another if statement so that if number of pieces is less than 2, it needs to be piece. If it is 2 or greater, use pieces. That is a great example of why bugs happen. You have to think of what people are going to do. Uh, we see in games all the time. You fall out of a map, or you bounce around, or do something. It is a great point. And again, the program is only as good as what you write it as. So, in our rush to be simple, we didn't take into account that somebody may only want one piece of bread. Um, it would be an easy fix. No, I like it. I like it because it gives us a chance to talk about, the things that we need to look at when we're actually getting into programming. Um, Design is extremely important. Uh, but yeah, so we literally, to fix that, we would say if number of pieces is less than 2, and this is another great example of why dry programming is so great. I'm changing this in one place. Anywhere that this got used, yes, exactly. Comments are amazing. And there's some other things that we would want to also compare here. So we'll show an example of that in just a second. But to fix the piece versus pieces. So now if we run this again, you'll notice now we get our logic back. It's 2 pieces or 1 piece. Um, the problem is, what if I say, see if Nixie's going to call it out? Yeah, we could totally do it. So we have a number of pieces, and we're going to now say, I don't like bread. Yep, yep. So this is, you'll hear me in Roadside. If you ever watch us talk, you will hear us say we hate end users. One of the reasons that engineers don't like end users is who is who is talking about I don't like bread and wants a sandwich, but they'll do it. Um, so yeah. So what happens if we run this? Well, first we're going to get an error, and the reason we're going to get is because I put a string here. Yeah, this is getting deep into use case logic. So, what did we not take into account? We didn't take into account that somebody may come in. This wouldn't be super important if we were explicitly setting these ourselves. But, what if we were using that input that I was going to start using? Do you want crust on or not? Users will be users. Very true. But yeah, if we were accepting an input, um, they could put in a string. We could forget to convert the string. They could put in a Y when we expected them to put in 1 or 2 or 10 or 20. We're not going to go deep into error handling just because that is a very complicated topic. and there are people who get paid a lot of money to deal with that. I am not one of them. I don't like error handling. I don't write programs for other people. But yeah, so we're going to assume that our users know that they need to put a number in. Anybody who has to deal with error handling needs to be paid more for error handling. I don't care how much money they make. All right, so we've talked about functions. This is why creating a function is important. We can change this in one location anytime it gets used. It affects anywhere else. We change it in one location, it affects anywhere that it gets used. That's the best way to say that. Race between the engineers to create the bigger software. Yeah. I don't think I've ever seen a truer statement. And that doesn't. The sad part is that doesn't just stick with software engineering. I think that is IT in general. So, are there any questions on what we have done so far? Yeah, users who don't know what they want until you've done something else. And then they argue that you didn't do what they wanted when you did exactly what they told you to do. Yep. Yeah, we get that in hacking too. All right, I am going to take a quick break. And we will be right back. All right, and we are back. We actually went further into this than I expected to tonight. Oh yeah, yeah, 100%. Yeah, I absolutely am not joking when I say I want to build that, and I don't even want to build it for a science fair project. I just want to have it at the house. That's why Roadside said you could not send that to me right now because I will stop stream and go build it. Uh, so we started talking about functions. We did some control logic. Well, after I see the video, we can test that. I am 100% okay with testing to see how long it goes before it melts or starts on fire. Maybe we'll do that as a stream in a controlled environment to keep it safe, of course. I figured. But then it stops yelling at me. Yeah, so from here, we've talked about some data types. There are some other data types that we should talk about, but not tonight. Those are a little bit more advanced use. You may have heard people mentioning arrays. In Python, we call them lists, unless we're using NumPy, but we don't want to get into that. Python also has a concept of dictionaries, which is build magnet batteries first. Yes, that is awesome. Uh, Dictionaries are a key value pair. Actually, I don't know that, Ace. Um, I'll tell you what we can do. I am not afraid to Google something. Find out together. So yes, kind of. 75%. Okay, come on, Nixie. Okay, no, I'll give you that. 75% is yeah. Everything in Python is a module. um, we haven't talked about objects. Uh, so I know what Nixie's going to say. It's 75% of programming is Google, the other 25% is Stack Overflow, right? Or maybe the other 15% or another 15%. Um, I'm not the only one that bangs my head against the wall on doing this stuff. That is good to know. Maybe I will be a real programmer one day. I mean, to be fair, when I'm hacking stuff, 75% of it's Googling, 10% of it's me getting frustrated when something doesn't work, 5% maybe hacking, maybe. Yeah, yeah, yeah. The rest for me is purely report. Yeah, yeah. That would be a really cool use case. Maybe so. Nixie came up with the great idea, Ace, that we should actually build a program that builds a peanut butter and jelly sandwich for us. Uh, when we do that, when we get to that point, because there's still some things that I want to cover with ducks. Yes, with ducks. When we get to that point, we may actually import that module because that would be a great use case for it. Um, but I want to cover how we import modules, and that's getting out of the language agnostic, which is what I was trying to stick to today. Even though we did actually code in Python, most of the concepts were language agnostic. I think we're actually at a pretty good breaking point tonight. We've been going at it for just about 2 hours. But before we end, I definitely want to open up for any questions, anything that anybody saw that they aren't sure about. We will make them cute pet ducks, Nixie. Pet ducks. The ducks can. Yeah. I avoid that at all costs, Ace. I think what we'll do next Wednesday, we will touch back on this topic. We will go into some more data types, some of the more complicated data types, if you will. That will not be completely language agnostic. I will try to compare it to other languages, though. So, yeah, yeah, yep, yep, yep. I my problem with those is I always forget exactly which way it's supposed to go. What was his name? I'm not even going to look that up. Uh, I will have that name for you next stream. Guido something. It, I think it is. Um, it looks right, but so actually, Nixie, while I have you here, does .NET C Sharp, whichever one you want to call it today. I know one's a framework, one's we're not going to get into that right this second. How do they handle dictionaries? Yeah, we'll do for loops. We'll do a little bit more complicated. We'll do some if else statements. Uh, yeah. So Nixie just named this series. This is going to be called Build a PBJ from now on, and we will do it on Wednesdays. Um, but for now, let's see if we can. So dictionary key value keys can be whatever data type within reason. Does C Sharp allow mixed data types for the key and the value? So can I have a dictionary with both integers for keys and strings? Can't do a dictionary in a dictionary. Okay, so in Python we can do that. Okay, so it's not that different. But yeah, next week we will cover some of these things that you're hearing me and Nixie nerd about. And okay, let me test in the morning. Well, I mean, if you want, we can test it on stream. I do have an IDE for C Sharp on here. I don't use it much, but it is on here. Let's see if we can find somebody to rate out to. And I'm not going to try to. All right. You guys want to go watch some Sons of Forest? All right. So we're going to bring you over to the one and only Gremlin. I am still here. We're getting ready to raid out though. Once again, I want to thank everybody for coming, lurking, chilling, hanging out. It is much appreciated. Make sure, if you are following, to stop by Monday. We are going to do a giveaway for reaching 100 followers. We're going to do a $50 Steam gift card. This was the last day I had to stream to meet the requirements for affiliate. So after Twitch updates, I should be able to put in the application. PBJ, awesome. I love it. No, seriously, that is the greatest, greatest rate message ever. Nixie, this is why you're awesome. But yeah, if everything goes well with that, then once that is official, we will do another giveaway of another $50. If that happens to happen before Monday, we will just do both gift cards on Monday. Monday, we are going to do a hacking streak. If I don't end up playing Phasmo to celebrate with Roadside, it'll be one of the two. Me and him will have to discuss that. But other than that, again, thank you everybody who came in. Thank you for the raid. Thank you for all the support. And with that, I am going to bring you over to Gremlin, and he will do all of the amazing things that he does. Hopefully, we're going to try this. But again, thank you all so much for being here.